Thank you, Roxanne.
So as some of you may tell, Dr. Pivovar is from the U.S. So if you can maybe talk a little bit about the organization, where in the U.S. you're based, and the type of research that you guys are currently working on.
Great. I work at the National Renewable Energy Lab, which is based in Denver, Colorado. It's one of the 17 national labs within the U.S. National Lab System. It's the only one that's exclusively focused on renewable energy and energy efficiency. And so we're in a very central location within the Department of Energy structure. And with the group that I'm in, we focus specifically on hydrogen and fuel cells. Over time, the role of hydrogen and fuel cells has been growing within NREL. We probably doubled in size over the last 5 years. And we do things, everything from making catalysts and making polymers up to demonstrating electrolysis at the megawatt scale. We store 250 kilograms of hydrogen on site, and we operate in a closed loop system where we take renewable electrons, produce the hydrogen, store it on site, and then bring back the hydrogen to do other research with within the facility as well.
Cool. In terms of those projects, do you want to talk about a little bit of who's involved in some of those application projects?
Yeah, so there's almost always collaborative efforts in these projects. We work with a number of universities when it tends to be materials development efforts. We work with different industry sponsors, and this goes from units like catalysis. So we work with General Motors, we work with Ford, and then we work with smaller businesses that are catalyst producers or developing technology. And then from the electrolysis side, there would be other companies like Giner or Proton Onsite, now Nel, where we have a lot of collaborative projects going on. A lot of the benefit of NREL is the facility we work in, which is the Energy Systems Integration Facility. And so the idea of how hydrogen and how fuel cells sit in an energy system and how to optimize their value proposition across the energy spectrum is how we play in. So we run a lot of analyses, and then we interact with these different industrial sponsors in a lot of state-of-the-art lab space to integrate these produce the devices, integrate the devices, and make them work.
That's really cool. Are there any pilot projects currently underway in the U.S. That you're involved in?
Yeah, so in the facility, we have the Energy Systems Integration Lab, and in that one we have basically a megawatt scale electrolyzer. So we can take continuous electrolysis or intermittent electrolysis. We do a lot of this because the future is going to be based more on using electrolyzers as dispatchable loads. And so we match solar and wind profiles to actually produce hydrogen when the electricity is available and cheap, rather than continuously, and test operating modes that wouldn't otherwise be operated under. So we have projects with both Nel and with Giner that basically run these electrolyzers under these kinds of conditions. And then we do other things like with Southern California Gas Company, which is the largest natural gas deliverer in the U.S., where we take about 110 megawatts of that hydrogen and we mix it with CO2 and we feed it to a continuous continuous process that's based on methanogens. And in a single pass, we can take 98% methane out of that for a power-to-gas type of application and re-inject it right back into the natural gas line. And it's working at these small scales, at the lab scale, and then moving up towards the megawatt. And our facility is expanding our Flatirons campus, which had been the wind site in the U.S., to take this 1 megawatt type of a scale and move it to a 10 megawatt type of a scale. Because those are the values that really start to become more interesting and compelling for the utilities and for other end users in this. And really, the difficulties of moving to scale are one of the things that we primarily focus on.
Great, yeah, and when you say that, do you want to maybe talk about the landscape for energy in the U.S. in comparison to regional areas of Europe? I know when you say the methane to power to gas, like why is that such a big deal and focus in the U.S.?
So I would say that power to gas or methane to gas is not really a huge issue in much of the U.S. Southern California Gas in particular is looking at it because the U.S. is so broad that there's different regions that have different concerns. And a lot of this is legislated as well at the state level. So California has progressive legislation on renewable gas, and there's actually standards that will force Southern California Gas to potentially supply 30% of their natural gas as renewable natural gas. And how they do that is one of the questions that they have in terms of how they remain viable and how they remain in business. And so by 2030, if they need to make a third of their natural gas renewably, they need to have projects now to basically figure out how to do that and how to move it forward. From a regional perspective, what we find is that the U.S. is so broad that in places like California, the utilities and the energy system are being driven largely by policy. So there's things like renewable portfolio standards and zero-emission vehicles that are seeking to push the business and the business cases and the solutions in one way. But then in the central part of the country, we have a tremendous wind resource. And so those utilities are being hit by these very large penetrations of variable renewables, and something that's much more akin to Germany or maybe the northern part of Germany. And then we also have a portion of the country with large nuclear fleets. And so then there's something there that's maybe somewhat more like a French situation where you have all of these different areas and they're all seeing different stressors, but they're all finding that hydrogen can play an important role in helping them solve it. And if we had hydrogen as a parallel energy carrier to either the electrons or the other energy inputs, natural gas, it would allow for different types of optimized and hybridized solutions to come about.
What would you find are the investment opportunities and challenges for hydrogen in the U.S.? Because I know in Canada we've got our own differences, and in Europe it's a very different in terms of government support and towards the investment for infrastructure. Can you talk about that?
Yeah, and you know, one of the most interesting things, I've been doing some of these roles in terms of promoting hydrogen at scale, and in the last 3 months there's been two major events. One was the Clean Tech Forum, which had a hydrogen executive summit for the first time ever. This brings together about 60 venture capital, investment banking, and other startup companies. And this was the first time ever that they focused specifically on hydrogen as the executive summit feature. And then NREL's own investment advisory board has a subset of these same types of research investment community, and they again made hydrogen the center point of what they're interested in. Now, the specific investment opportunities are evolving, and a number of these VC, the venture capital firms, they were actually already in hydrogen at some level. They maybe had one play or two plays, and what they were looking at is how long until this happens for real, what the real options are. And one of the big things that's changing is that with the Hydrogen Council coming forward, with major industry pushing this, the status is different in that they recognize that the momentum behind hydrogen is different, and that they realize that it's going to be something that's real, and there's real opportunity in the venture capital area for different types of investment.
When you say opportunities, that alludes to the fact that there's obviously some growth opportunities that are happening for other players in this field. What does that look like in terms of like dates and deployments? What do you foresee happening in the next couple of years in the U.S.?
So there's some areas like hydrogen fueling stations that through state support, they're already happening at some level. And so there's a number of companies that are doing things specifically either in the electrolysis space or in the fueling infrastructure space. You can see a lot of them, you know, at an event like this, more than anywhere else probably, and you can see where the value proposition is and where they're trying to come into. Other companies are always trying to figure out other places to feed into that, but I really think that, you know, this venue is one of the best venues to basically see where the people are at and how they're trying to fit in both at the very small business level and then at kind of larger scale other opportunities as you start trying to go towards the gigawatt scale versus where we are today.
Great. So in terms of, like, you mentioned all the exhibitors that are here, if there are particular companies that are interested in getting involved with some projects in the U.S., is there opportunities for foreign companies to do so, and how can they get about to do that?
Yeah, absolutely. And we interact with foreign companies all the time. We've had a number of institutions send us over equipment, and we have infrastructure that's not widely available. So there's some companies who send us units simply because they lack the ability to handle the power and the gas and the other requirements that are from it. And there's things like our Electrolysis Testbed, which is a megawatt scale test bed, but it's actually been set up in a way that it's a complete test bed, but we can pull out the drying system, we can pull out the compressor system, and we do a lot of work with compression companies, we do a lot of work with the electrolysis stack manufacturers, and we can bring in just the individual components and make them work. And sometimes we do that on kind of a fee-for-use schedule. Basically, they need something done and they can't do it themselves, so they come in and they work with us and they put a contract in to pay. But most often this happens in some sort of collaborative research agreement where we're trying to understand what will happen to their system if they run it and run it hard and stop it, or try to fit the wind profile or a solar profile. And will that, if they've developed these technologies to run continuously, how does that impact their durability? What does that mean for their lifetime and other types of things like that?
Great, that's great. Do you have any advice for any of the companies here if they wanted to get involved, of where they can start to do so in terms of entering the U.S. market?
So from the U.S. market in particular, I think that they would understand better than I would. However, if they wanted to get access to NREL's lab, contacting me personally, looking at the website, doing anything along those lines, we have the ability to basically test at any scale that's being developed till today. And we're trying to basically integrate that into demonstrating that what most of the people here believe the future should be can be the future, and that we can help de-risk it and make it cheaper for them to move it forward.
Great. Is there anything new in terms of, like, big opportunities in the next few years that you have going on internally?
The hydrogen at scale efforts have been growing substantially over the last few years. There's actually a funding opportunity announcement where the concept paper, which is a requirement, closes April 8th. So there's still enough time for companies that are interested in it, but most of them would already have it together. The concept paper isn't a huge lift, but the full applications, and this is a $31 million solicitation, and in the more demonstration areas, it's a 50% cost share match, but in the more low TRL early term research, it's only a 20% cost share match. That's open right now through the Department of Energy. If you wanted to find out more information, it's on the Department of Energy's website, and you could talk to me specifically as well. You'll see many more of these things happen, so even if you'd missed this round of it, there'll be many more, and the rate of funding hydrogen as a large-scale energy carrier is going up in the U.S. Historically, we focused almost exclusively on transportation, but there's been a shift to making renewable hydrogen, and basically the mottos of hydrogen at scale are how do you make, move, store, and use hydrogen more cheaply, and anything across those value propositions is a possibility to get funding and to do projects and to interact with institutions like ours in the U.S.
Great. I'm going to open it up to the audience for questions. Does anyone have any questions for Dr. Pivovar at all? No? Okay. Well, perfect.
Do you see any potential projects happening like they're doing in Germany where they're doing electrolysis for refining applications of hydrogen?
So there is the Refine project that's being funded currently, and we interact with Syntef at some level about the project. But clearly, you know, when we talk about markets for hydrogen, a lot of times we make the hydrogen and we just assume that somebody's going to take the hydrogen. But for a long time, the largest market for hydrogen consumption is going to be refining. And in places that can valueize the renewable or clean aspect of it, and places that also have a built-in infrastructure to handle it, where it can be done most cost effectively, maybe where there's excess solar or low-cost electrons much of the time. Demonstration projects that would actually tie renewable hydrogen to refining would be great projects. Coming up with the demonstration dollars to make them happen in the US would be a wonderful thing. California would be a great place to start with it, in my opinion.
Yeah, I agree. Do you see the refineries being motivated at all to incorporate renewable hydrogen? Does that somehow give them some sort of a greener fossil fuel?
Only in places like California where there's a LCFS type of a value proposition for it. One of the struggles for hydrogen is that everybody wants the green aspects, but they cost something in today's market, and if you're not willing to pay for it, it's difficult to understand how you will do it. And if you're specifically, ammonia and wind are two of the places that we look really a lot for big places that hydrogen could be used. What happens is that those are basically large commodity markets with small margins and high energy costs. So if you're making 2% on what you're investing and your energy costs are 90%, you can't electively pay 20% more for this. Green data centers are a place where energy costs are still high, but Google or Microsoft or Amazon can decide to do it because the energy costs tend to be a lower percentage of it. In the refinery, hydrogen's only a fraction of the value of the crude that you sell, so it would be easier to do it, but most of the places aren't going to spend more on green hydrogen just to have green hydrogen. In part because they are then putting it into a fossil fuel that's still being burned somewhere. So it's good and it should happen, but unless it's being policy driven, the economics, especially at that scale, are particularly challenging.
Do you know the driver behind the 10 megawatt project happening here in Germany and why that's kind of...
The driver, I don't know the driver specifically, but if I were to project on what I think the drivers are, it's such a large market for hydrogen, and it's a better market than something like power to gas, because usually we take methane to make the hydrogen, so to take the hydrogen and turn it back to methane would be one of the worst value propositions. But if you're actually displacing hydrogen from an application that hydrogen's already being used in, it has a higher value proposition. And we use so much, we reform so much methane to stick hydrogen into crude oil that for the next 10 years, the refining process in ammonia will be bigger than anything that transportation directly in fuel cells could do. So if you can find your way into those markets that are huge and exist and start removing the step of steam methane reforming, it's a better value proposition along the way at some level.
All right. Thank you. That's about the time that we have today. Thank you, Dr. Pivovar, for joining us today.
Thank you, Roxanne.
Thank you.